In the last video about significant figures, we saw an exercise in which we calculate all the results using significant figures and the rules. But the question is, what happens when we don't have significant figures only, but also we have uncertainties? How could we get the value with the uncertainty? So this is what we're going to do in this video. So just for you to remember, what we established was that we have three different times measured with different instruments, and we have a distance, and we want to determine the speed by dividing distance and time. So I'm going to start by adding a relative uncertainty and absolute uncertainty to the numbers. So first, let me write here the uncertainty for the uncertainty for time, we're going to set that in order to get the uncertainty of time, we're going to use the random error. So uncertainty by random error. So we have two options when we have random errors. One option is to use the standard deviation, and the other option is use the half range. Okay, when we don't have too much data, we use the half range. When we have more than 15 data, so we can use the standard deviation. So we're going to use the half range here. Half range, so is just maximum value minus minimum value divided by 2. So in our exercise, maximum value will be 4.3, minimum value will be 4.03. So in our case, our uncertainty will be 4.3 seconds minus 4.03 seconds divided by 2. So if we perform the division, the subtraction and then the division, (4.3 minus 4.03), and then we divide it by 2, we have 0.135. Okay, that's what we have as an answer here. And in this time is when we apply the rule for significant figures. What we get as time, when we've calculated, we use just one decimal place due to the rule for significant figures. So we're going to set the uncertainty just with one decimal place. So in this case, our uncertainty will be 0.1. So the time will be equals to 4.2 seconds, that is the average, 4.2 plus or minus the absolute uncertainty, that is going to be 0.1 seconds. Okay? This is the way we can decide what is the absolute uncertainty for our measurement. Okay? When we have random errors. Now for distance. For distance we don't have too much information, so we're just going to add the uncertainty. Let's say that is 0.05. We have two decimal places, so we can assume that the uncertainty is on the hundredths place, and we're going to put 0.05. Okay? So we're gonna have that the distance is 3.00 plus or minus 0.05 seconds. Meters. And now we're going to determine the velocity. So the velocity was calculated by doing the division. We did it in the other video, so you just can check the other video, in which the division gets us 0.72 meters per second. But how to determine the uncertainty for velocity? There are some formulas that you apply when you have absolute uncertainties in order to get the uncertainty of the division. So the formula, when you have, for example, that A is the addition of 2, so the uncertainty of A, or subtraction, will be just adding the uncertainties. Okay, doesn't matter if it's addition or subtraction. And when you have division or multiplication, this is the case, or division or multiplication. Okay, when we have this, we have to decide the uncertainty by using relative uncertainty. So the relative uncertainty for A is equal to the sum of the relative uncertainties. Okay? So here we just need to get the relative uncertainties in each case. So velocity is the multiplication of distance and time, so relative uncertainty for velocity is going to be relative uncertainty for distance plus relative uncertainty for time. Okay? And we have these values. So we just need to determine the result. 0.05 meters divided 3.00 meters plus the time 0.1 seconds divided 4.2 seconds. Okay, you can see that the units are cancelled because it's relative. So when we have relative uncertainties, it should be a percent. Okay, so the relative uncertainty for the velocity is going to be 0.05 divided 3, so 0.0617 plus 0.1 divided 4.2, 0.024. Okay, if we add these two, we just have 0.0 4 and 7 is 11, 41. Okay, this is kind of 4.1%. So you can see that the relative uncertainty is very small. Okay, usually when you have relative uncertainties less than 10%, we have a very good experiment. Okay? Okay, so now we're going to move to get the value of the absolute uncertainty. So the absolute uncertainty will be relative, in this case 0.041 times the velocity. So 0.041 times 0.72 meters per second .03. So 0.03. Look at that, I round to the same decimal place that I show with significant figures. Okay, it could be possible that you get as a result here, for example, 0.3. So in this case, what we have to do is to round this number to the other significant figure, because the error spreads in a way that we lost this value. Okay, it happens when you measure. So the final answer will be velocity 0.72 plus or minus 0.03 meters per second. And in this exercise we use absolute uncertainties, relative uncertainties, and we determine relative uncertainties by using the rule for uncertainties. So I hope that this video helped you. I hope that if you have any question, just tell me, just send me your comment. If you like the video, like it, or share it with somebody, and subscribe to my YouTube. So see you in the next video. Have a nice day. Bye bye.